Hi everyone, I'm Umer Salman, uh, and I'm going to be talking about UVS Ops, which is uh, a Cake PHP project that we work on, and it stands for Ultraviolet Spectrometer Operations. So I'll get to what each of those words means in a little bit, but first a little bit of intro of like the mission, me and my team, and what we needed to build a Cake PHP application for. So Europa Clipper is a roughly $5 billion NASA project, which is going to be a spacecraft that launches this October. And one small part of it is an instrument made at my organization in San Antonio, Texas. And so that's an image of Europa Clipper. Well, it's like an artist's depiction going over Jupiter's icy moon Europa, which I'll talk more about later. So what I'll talk about is me and my team, then the Europa Clipper mission, then the application we make using Cake PHP, the tools and libraries we use, and then I'll walk through the actual application itself, and then we'll wrap up and ask like some questions that you may have, or I'll answer some questions that you may have. So who am I? If you were at CakeFest last year, then you would have seen this slide already, but essentially I'm a research computer scientist at Southwest Research Institute. We're a nonprofit R&D organization dedicated to building out technologies from deep sea to deep space. So that includes everything from like oil pipeline crush testing to fire-resistant materials, all the way up to NASA and European Space Agency spacecraft, which is the part that I work on. And I went for electrical and computer engineering at UT Austin, and have worked in robotics and cybersecurity, but that doesn't mean I'm new to PHP or web development. Back when I was little, my sister and I got a Nintendo DSi, and I found that the web browser on it actually ran JavaScript. And so then I started Googling around, and I found that people had made a whole like Nintendo DSi community, making different like social networking sites using PHP and the web stack. And so then I started working on that, and then I was like, wow, this is pretty nifty. You know, I can make a lot of stuff with this. Then from there, I just like continued going forward. I also like lots of other things like cars, tropical weather, DIY stuff. Yeah, all that. There's just a lot of topics that I enjoy. As for my group, we're a small group. There's 3 of us that are actually building the web applications part. We have more people who work on like the C++ code or IDL, and then the scientists and engineers that build the spacecraft and whatnot for the missions. So in the group, they've been using Cake PHP since the 1-point-something days before I was there. But since then, I joined about 3.5 years ago. And we've actually ported pretty much all of them from majority were on Cake 2, and majority are now on Cake 5. There's a few still on 4, but we're pretty close. And when I'm talking about majority, we have 45 plus of them. So we actually have quite a big number of applications running Cake PHP. And we use the whole Cake PHP ecosystem in order to continually improve. So we modularize a lot of these applications for these different science operations centers, and that way different instruments and spacecraft share a lot of the same code base, and we can just turn on and off different features of different spacecraft. And then we also use plugins. Thanks, Mark, and many of the others here, Jose and Jorge, and yeah, pretty much a lot of people in this room. We have a lot to thank you guys for. For our styling and front ends, we mostly use Bootstrap stuff. Then we work with a lot of stuff from other organizations and other people within our own organization. So that means that we have to have our Cake apps integrate with a lot of different other software. So those might be written in IDL, which is kind of an aerospace-specific programming language, Python, C++, Fortran, JavaScript, like, the whole works. And so the amount of knowledge and like code base that we have goes back decades. Like as an organization, we've been around for 75 years, and so we've been working on a lot of different projects. So Europa Clipper is the one that I want to talk about today, and what it is a spacecraft to research Jupiter's icy moon named Europa. It has a sister spacecraft named JUICE, which stands for Jupiter Icy Moons Explorer. And so Europa Clipper is a NASA project, whereas JUICE was European Space Agency. And so JUICE is exploring Jupiter's moon Ganymede, which is nearby to Europa. And JUICE launched last February 2023, while Europa Clipper is launching in October of 2024. And both of them will be doing a few gravity assists, and we'll end up both making it there in 2030. And so when we build these applications, we do have to look pretty long term when we think about what we're doing. So you may ask, why? Why are we sending spacecraft to Europa and waiting 6-7 years before we even find out anything? So there's a lot we can thank space research for, specifically, including laptops, water filters, like batteries, solar panels, and so much more. And secondly, Europa is actually it's an icy moon, so it's actually filled with water. And while the outer shell is ice, the inside is pretty much an ocean where you would think of land would be. And so I have an image here that shows how much water is on Europa. So even though Earth is so much bigger, the amount of water is represented here, whereas Europa is much smaller and actually has twice the amount of water as Earth. And so we can kind of think of it in terms of when we're looking at the deep oceans of the Earth that are kind of removed from the civilization world, Europa might have similar features of maybe there's underwater geysers, or maybe there's potential for life there. So that could be on a completely different path from anything we've seen on Earth. And then of course the water there, we don't actually know what's in it, right? We just based on previous missions, we believe there's water there, but we haven't actually gone and touched it. And so the actual mechanics on Europa have where the water can actually plume up, and so we'll actually be able to potentially fly through a water plume and determine what the composition of elements are within the actual water. And so a little bit more about the spacecraft is this is what it looks like. This is a 3D model made by NASA about it. And so this is about 16 feet or 5 meters tall, and about, I don't know how clear that is on black, but it's about 100 foot wide, so about 30.5 meters when all the solar panels are deployed. And so what my team works on is just this tiny instrument on board called Europa UVS. So this ultraviolet spectrometer, what that does is, I don't know if y'all remember your electromagnetic spectrum, from back in grade school, but that goes from radio waves to gamma waves. And so the ultraviolet spectrum, we're specifically looking from a range of 55 nanometers to 210 nanometers. And the reason why we target this is if you think back to the the 3D glasses where you have the red on one side and blue on the other side. So you can imagine that same sort of thing, but on a wider range, and you see different things with both eyes. You're able to see a much bigger picture of what we're actually looking at. that's happening actually on that moon. Additionally, the organization I work for, we also make this instrument, the mass spectrometer, but I'm not on that team. I can talk about it later, though, if people have questions on it, but I won't know as much as compared to UVS. And so for the application we build, and I'll demonstrate it in a bit later, but it's actually publicly accessible because a lot of our NASA-funded things are open to the world. And this is like a view of what the homepage looks like, but I'm going to talk about what libraries we use to make it. So obviously we use CakePHP. It'd be a little awkward if we didn't. And I came here and talked about it. But we like CakePHP for its ORM, user accounts, all the different plugins. So for the user accounts, we use CakeDC users in this case. Then we like that it's server-side because it allows us to communicate with some of our other tools. Like I mentioned, C++ and so on. Then we use Fabric.js, which allows us to have like HTML canvas elements that the scientists can then use to split up these detector images. We use JavaScript Viz timeline to actually plan out different flybys of different moons and planets. And so that's kind of where the scientist looks at the final state of what they've built. We still have a lot of jQuery going on. For Ajaxing, we have a small calculator that you can drag and drop in a window. And then something I'll show in a little bit is we have a big, essentially Excel form embedded within the web pages that the scientists use for figuring out the different data rates that and the amount of data that they're able to package in the packets when communicating with the spacecraft. And then we use jQuery time picker, which is the only time picker with sub-second picking. Everything else, is kind of operated on more like how doctor's appointments are, where they expect you to have oh, it's at 10:15, but we require millisecond and nanosecond, depending on the use case. And so if someone wants to build one that has one, I would very much appreciate it. But currently there is not one. And so as far as I know, us and PHPMyAdmin are the only projects that are stuck with that problem. So now the actual application. So I'm going to go through it the way that the scientists kind of do so. So as I mentioned before, we're using CakeDC users. And I can do my login. So there's stuff that's public facing that everyone can do, and then there's stuff that only specific scientists or engineers or admins can do. And so things would be like making cards. So this is that canvas thing that I was talking about. And so what this is representing is that same 55 nanometer to 210 nanometer scale of the detector space. And the scientists can draw out lines which are essentially creating zones that the detector can then know, hey, there's stuff that's important in here, and so run it at essentially higher resolution. Because as you can guess, space in these data packets is at a premium. And so we're just one small instrument on that giant spacecraft. And so we're only given a small allocation of data volume to be able to send back and forth. And so this is in a process called binning. And you can see below, this is that Excel type thing that I was talking about, where the scientists can see what the limits are so where it goes to start and end. And then, more importantly, the data volume rates and how much science data compared to overhead we're getting. And so all of this is compiled together, and it uses these parameters, which are actually parameters from the instrument itself. And the instrument also has like multiple modes, which is actually the calculator bit that I had talked about earlier. And so this is that calculator where the scientist can do those calculations on the fly without having to draw it out, for every small calculation they may want to do. But let's say I want to go ahead and save this card, right? I can see the other cards people have saved. I can also create a spectral image. So this is running some IDL locally, like code that creates a different kind of image. And so this was written by one of the scientists, but we just hook into it and present it on the same web page. I don't know what this means, as I'm not a scientist, but apparently it's useful for them. I believe it's related to like the different quantities of different elements. But as I mentioned before, we also use Suite Alert for like to show the user what's going on. So let's say I want to save this card. And so then I have Suite Alert tell me, hey, you don't have any of the information there. And we, this is where the scientists can set the information of it. And then they can also click this, which will give them the stuff from that canvas and just go ahead and input it into the details. So we can just go ahead and name it Umer. And so you can decide whether you're still working on it or you want it exposed to the other scientists. And then you can set a color for it so that you can, kind of name a different kind of naming, keep things like categorized in a sense. So now we can save it. And then we go to the second part, which is called the stem. And essentially this is more of a broader picture of that same thing. So you can see that same line representation here. And this is more of like an engineering type tool where there's like these calibration dots, and they basically use this to determine if things are like functioning right and like looking things at a bigger picture. But it's kind of doing the same thing as the other one. And you can set up different regions of interest that matter to them. As for the application, this is where the observations and stems can be tied together. And so you can drag the cards you made on the first one and combine them. And so this is using the associations within CakePHP to link these different ones together, the observations and the stems. And so you're basically combining these templates. And then we also have a drop down where if this were, if it had filled out with a bunch of other templates, then we could just checkbox off a whole bunch of them. From there, we actually get to the important meat part of the application. And so on here is where the scientist can then see the flybys. So this one is Europa Flyby 18. And so once that loads, and so they can see the different modes that the instrument will be in. So green is a stare mode. The light blue is like a scan mode, so like whether it's like sweeping in the detector space or whether it's just like staring at a point. And so the point of this is we can then view the cards that we have and drop them on this timeline and see where it matches with images of what the spacecraft will be looking at a specific point in time. So the this is using Viz timeline, and we have a bunch of parameters that we ingest in, which I'll go into a bit later. But those parameters have info, and it tells us more about what is at that like time and date. So this is April 26, 2032 at 1900, and we can zoom in to smaller units. But we can move the cards around and shrink them and so on. And we also have, here's like those time pickers where you can zoom into specific spots and run one of the scientists' code to see things like exposure levels and such like that at those timestamps. Then what the scientists then use is this all gets put into a CSV file, which looks like any other CSV file, but it has the information on the instrument. If I can zoom in on here. And then it has like the start and stops for each of the regions that we set up earlier in those associated observation cards and the stim cards. And then you can also see an altitude versus time plot, which this is just Plotly, but it's showing over this flyby how close it gets to Europa and then back out. And so the cards that I put down here, those are actually going to later snap onto data that we're going to be getting in the future. And so that's why it kind of looked like it was huge, but we'll be able to fit that better in the future. One thing that this is missing that I would like to add is, so these images come from another tool that we make that I actually covered last year a little bit called GeoViz. And so what that looks like is it's another CakePHP application. And with this, you can see both in the past and in the future what all these spacecrafts and more, if you're logged in, looked at or will be looking at. And so we use this often where the scientists will run this with different timestamps. And here, I'll go ahead and run one. And so this is using DuroMark-Q. However, this is one of the ones that we're looking to do more of the Docker remote processing that I talked about last year. But essentially, we take this and it makes some graphs or some plots that look like the one that we have here. And so we can know way in advance what is actually interesting about the flyby. So we don't want to be wasting power and data if we're just going to be looking at blank space, So if we can go ahead and just turn off the detector at that time while we wait for this to load. So, on January 1st, 2001, Cassini spacecraft was looking at Jupiter. Cassini was a different spacecraft that was decommissioned in 2017. But then on January 3rd, it wasn't looking at anything. So in this case, we would go ahead and just turn off the instrument and save power. But this is, as I mentioned before, another CakePHP 5 application. And you can choose different star maps and things like that. And you can run these in a queue. And so we use that as well where it then shows up in a queue, and the scientists have a mode to batch process these as well, because they'll go ahead and just set up a whole bunch of timestamps and have like 300 of these, which is why the queuing is very important to us. Yeah, so you can see it starts to go here, and you can see the info on what parameters were set. So a lot of our applications are essentially like wrappers above like Linux programs that allow it to be abstracted from everyone typing on a command line and typing all these parameters in and potentially screwing that up. Because if you miss a parameter or like mess one up, you don't know what you're ending up with is actually what you're intending to. And so we do this for many such missions. And while that's going, what I'm intending to do is make it so that there's like an API here that just calls the other one, because they're both actually using CakeDC users. And so, you know, I should be able to like click and drag from here to here and say like, hey, go ahead and run that other program at this certain amount of time step, and then have that go in the background. And then when the scientist comes and looks later, they have a much more fine-grained view of the specific stuff. Another thing that's extremely relevant is it supports different parameter sets. So as it gets closer to launch, they work on these parameter sets for the flybys to basically fine-tune like where the spacecraft is going to be. And so we can see those. We can see the ones with G are flybys of Ganymede, E is Europa, and in this case we just have Europa and Ganymede. But for other spacecraft, they might go by Io or some other moons as well. And then I mentioned we have JUICE, which is another spacecraft, which is that like sister one. And because we actually make the same instrument for both, the site has now changed to being able to do everything in JUICE UVS ops mode. And so just by changing the tab. And so we can actually share cards. Someone on the JUICE team can be like, hey, you know, this is relevant to us. Is this also relevant to you guys? And I can grab the cards that someone made for Europa and stick it on JUICE. And in the background, it went ahead and linked the different parameters here, like this framing overhead, which is specific to that instrument. So we're using the ORM pretty heavily in Cake with these associations and whatnot. This should be done. And so now we can see a movie of the one that I mentioned before. We can download it and then see the images at the different time steps. And so there's definitely spots in here where, you know, it's more useful than others. And we can use that information on the other page. And so right now, instead of the API, you have to go and download it as a tarball and then upload it into the admin console. So in all of our sites, we end up with an admin console, and we basically have file ingesters, because a lot of scientists work in CSVs and Excel files. And so we're using the CakePHP file uploader plugin, and it gets processed in here and gets added to the information that was in use earlier. We can also manage users, turn on and off access to different parts of the site. We can have the multiple missions, like I mentioned. So in this case, we have Europa Clipper and JUICE, but on our testing version, we have a whole bunch more, just to, you know, confirm that, okay, if we had another instrument of the same type, whether that would end up the same. So this whole thing is very multi-mission oriented. the flybys can be seen here. And then this is where the data starts getting like really massive, is in these parameters for each of the flybys. And so we end up with, you know, many thousands of them with all these different parameters. And so this is actually somewhere where we ended up having some trouble going from 4 to 5, where like it's just trying to put that in the Finder, like too much stuff. I'm not exactly sure yet, but it's not happy with it. And so if we do a limit on it, then it's okay with it, but there's something else going on, which is why this one is not able to go just yet. And then there's the different modes where you can change the colors of them, which is using that other JavaScript library, Spectrum, activities, which are the different types of like when the activity names are going to be on and off per flyby. The observation cards that you saw, the stims, yeah. And so these are all basically like the baked ones. You know, we're just add, remove, but they have a lot of associations with them. And then we have all the images where you can pull in the ones from that other connected one. And so for all of these, if we get a new file, you can either do a merge. If like you're saying, hey, I already took this set and I want to add more, you can merge them and say like, okay, I'm extending. Or you can say like, no, just screw all the other ones. You know, we have new information that's better, and it'll just delete all from the table and stick in the new one. Then we have yeah, so these are both still very much in progress. And they work in tandem. So that's something that is definitely in the process to improve more, is the tandem functionality of these two. Where I have in my profile, I'm able to you know, set like an API token that allows me to send these plots straight to the other one and refer to like these projects in both cases. But as I mentioned before, we work on a lot of different projects, and so that's something, you know, that's not as core to it, and so it's one of the things that's more on the backlog compared to the other things. Then we had that's actually more or less it. As a small aside, here's what like the certificate looks like for Juice. And so you can see it launched April 14th from French Guiana. And I'm hoping the NASA one will be just as cool or cooler. But we'll see. The launch window starts on October 20th. And you know, that provides a time that, because you don't know like weather permitting or like other potential issues. So like for a previous spacecraft, we actually had where it got delayed so much because it was launching from Florida, and there was one hurricane, so it was brought back in, and then there was another hurricane, and so it was actually like a long time later when it actually got launched compared to when the instruments got on board. So so with that, I pretty much open the floor for questions on the application, any of the tools and libraries we use, the mission itself. Yes, feel free to ask.
Hello, hello. Yeah. So when the spacecraft sends back data, it goes through the deep space network, I assume?
Yes, that's correct.
And then what? How do you get it into your database? Like, what's the process?
So that's actually a really good topic that I didn't really cover. But we have a whole, in this case, this is more of a pre-planning tool. And so this one is more for like planning and then sending to there, which again, data is still a premium going both directions. But in that case, some of our other science operations centers, I talked about in my CakeFest talk last year, but we've improved it a lot where we have the data, like different spacecrafts and organizations, because we work on so many, put them in different places. And we have a tool that basically goes and either grabs them from like, could be like an FTP server, could be wherever NASA or the supporting groups, which could be any number of groups. So like in this case, there's Colorado Boulder LASP, there's Arizona State University, there's Jet Propulsion Laboratory, Johns Hopkins APL. Like there's so many places it could go. And so it pulls from those and then runs through a Python pipeline that converts the data from, it's called L0, which is like, you know, basically the raw data packets. It goes to L1, L2, and however many like calculation steps are needed. And then from there, the last step from Python then ingests it into the Postgres database that we then pull from. So from the Cake side, it isn't yet, but in theory, it should be read-only. And one thing on those we've been looking at is using timescale DB. I don't know, has anyone heard of timescale DB? It's kind of like a plugin on top of Postgres that is more for time series databases, where instead of having like a key, because like you're never going to go and say, oh, actually at this time, the value was 24.86, not 24.84. And so they get rid of the data, like the primary key, and instead set the primary key on the epoch or like the timestamp. And so it actually allows for a lot of cool things that we haven't gotten to yet, but it'll put the data in buckets. And as like time goes on, it can say like you're using it for like a thermostat. You don't actually care what the specific temperature was last year. And so for last year, it'll condense those down into like, a single data point and keep your database from like infinitely expanding. For us, the scientists may want to go back and compare it to like when it was in the lab or something like that. So we can't get rid of that old data, but I imagine there are use cases where we can use that. So it's something we're feeling out right now.
Cool.
Yeah, I think.
Metrics, awesome.
Did you say matrix?
Metrics.
Oh, metrics.
Matrix too, though. Sure. Anybody else? Questions?
Is there anything anyone wanted me to click on more? Because I know I kind of blazed through the first bit.
Thank you, and that was really interesting. That was awesome. I'm going to ask a question from a position of ignorance, so forgive me. I don't know much about electrical engineering, but how does a system reliably gather data in space with all that radiation? It must flip bits, erase RAM, all sorts of things. How do you reliably collect data and have it piped in from space? Because I only do terrestrial programming, and I don't have to worry about that kind of thing. Tell me, please, because that's fascinating.
No, that's a very good question, and definitely out of my pay grade. But I can answer to how we test it is at our facility, we actually have a radiation testing chamber, and there's a lot of PhD scientists who know way more about it than me. But there's a lot of radiation from the sun, even all the way out at Jupiter, and then Jupiter has its own magnetic fields that are pretty strong as well. And so there is a lot of stuff we have to shield for, and yeah, I don't actually know the specifics, but I do know that we take a lot of consideration into it, and there's stuff like positioning of where like the instruments sit and different kind of shields. So actually, another cool mission that is probably one of my favorites is the Parker Solar Probe, which is actually traveling inside the sun's corona, so inside the sun's outer atmosphere, which you can imagine is very hot. And there's a ceramic shield sitting in front of it, and that's like the one end is how many thousands or millions of degrees or something, and the other end's room temperature. And so we have some really good materials for doing shielding of thermal, of electromagnetic that we do. And then another thing is the satellites are huge. Like like I mentioned before, this is 100 feet across, like with the solar panels. And then the dishes in the deep space network on Earth are also very large. And so that lets you like compensate for just the broad distances. But yeah, so I don't know the answer to your question specifically, but there's definitely a lot of information on that subject.
Thank you.
So yeah, so these slides are available. They have links to each of the resources I showed. And then, as always, I actually upload everything that's like on my site and whatnot to my GitHub. So there's actually like my speaker notes inside the the HTML for this page as well, which has a few other links like the actual videos of it doing like the gravity assist for each of these spacecraft that are in there. And then, as always, I'm on the Slack for CakePHP, or you can contact me by email. But that's it from me, unless there's any last questions.